Question 3.33. 2-point charges are located at two corners of a rectangle as shown in the figure. What is the electric potential at point A? And what is the potential difference between point A and B? So here you have 2-point charges located at two corners of a rectangle. Charge Q1 we will write as -1 microcoulomb, which is equal to -1 times 10 to the power -6 coulomb, and charge Q2 as 3 microcoulomb, which is 3 times 10 to the power -6 coulomb. The distance of charge 1 from point A, we will call this R1, and that is equal to 0.250 meter. Whereas distance of charge 2 from point A, we will call this R2, and R2 is equal to 0.500 meter. We need to find potential at point A because of these two charges. We know that electric potential is a scalar quantity. So if we were to find potential at point A, we need to add electric potential at that point due to charge 1 and charge 2. So we can write V1 as KQ1 over R1 and V2 as KQ2 over R2. Since K is common in both, we can take it out and write Q1 by R1 plus Q2 by R2. Let's substitute to calculate for potential at A. K is 9 times 10 to the power 9. Q1 is -1 microcoulomb. R1 is 0.250 plus Q2 is 3 microcoulomb and R2 is 0.500. That gives me potential at point A to be equal to 18,000 volt, or you can also write this as 1.8 times 10 to the power 4 volt. So this is part A of the question. Now let's solve for part B. In part B, we need to find what is the potential difference between point A and B. If I want to find potential difference between point A and B, I need to know what is potential at A and what is potential at B. We already found potential at A while solving part A of the question. So now we will first find what is potential at point B and then take their difference. The two charges remains the same. We will call this Q1 and this as Q2. But now the distances of these charges will change. Q1 is located at a distance of 0.500 meter from point B. We will call this R1. And Q2 is located at a distance of 0.250 meter from B. We call this R2. Now let's substitute to find potential at point B. We write VB to be equal to potential due to 1 plus potential due to 2, which will be equal to KQ1 over R1 plus KQ2 over R2. Again, take K common outside, so we get VB to be equal to K Q1 over R1 plus Q2 over R2. Substitute. K is 9 times 10 to the power 9. Q1 again -1 microcoulomb. Distance R1 now is 0.500 plus Q2 3 microcoulomb and the distance is 0.250. When you solve this, you get potential at point B to be equal to 90,000 volt, or you can write this as 9 times 10 to the power 4 volt. So I found potential at point B. We know potential at point A. We can find the potential difference between point A and B as VA minus VB. So solve. VA is 1.8 times 10 to the power 4 volt and VB is 9 times 10 to the power 4. And when you solve this, you get the potential difference between point A and B as -7.2 times 10 to the power 4 volt.